Welcome to the 2023 Winter Classic Student Cluster Competition Studio Update Show. Now, here are your hosts, Dan Olds and Addison Snell.
Hi, everybody, and welcome to another 2023 Intersect 360 Research Winter Classic Invitational Student Cluster Competition Studio Update Show. I'm Addison Snell along with Dan Olds. Dan, the students have been chugging through the competition, and they do that along with the help and really support, big-time support of the mentor organizations. And we're here talking to a major mentor this year, AWS.
Yes, we are, and they mentored the ever-popular GROMACS application. Let's go ahead and bring them in. We've got Sean Smith and Evan Bollig here. How you guys doing today?
Good. It's good to be here. Thanks, Dan.
Sean, Evan, thank you so much for the mentorship that goes along with this. People are by now aware from watching the updates that the students go through rotations of different challenges with mentor organizations, not only hosting that particular challenge, but introducing the students to that application and the skills they'll need in order to get that to scale. That's a major endeavor, teaching that to 12 teams from 10 different universities. Thank you for signing up and doing that yet again this year.
Oh, of course. It's always a pleasure. You know, these students are super talented, and it's a pleasure to work with them.
So how'd you have them set up this year?
So we had them set up on a cluster using a service called the AWS Parallel Cluster. So this is a service that creates an HPC cluster in the cloud. It runs Slurm as the scheduler, and we gave them 3 different compute options. So the first was an AMD EPYC Milan processor. They had 8 instances, each with 96 cores. The second was a Intel based processor, and the third was actually the wildcard, which was 2 GPU instances. So they really had a wide variation of hardware that they could choose from to see what got the best performance as well as what got the best price performance.
What did they end up gravitating towards? What was the winning combination in this case?
So the HPC 6A, which is the AMD EPYC based instance, was the best, both absolute performance and best price performance, which was what we expected, but we also saw a lot of the students running jobs and experimenting with different hardware types and really seeing that for themselves.
Which is what we want to see.
Exactly. And when we were talking about this in advance, we noticed that by looking at both performance and price performance, and with a couple different choices for instances, this really presents the students with something that's a real world challenge. And you're using GROMACS, which is a popular HPC application. How did they respond to that?
So Sean, sorry to interrupt you here. I just want to call out the best true performance we found HPC 6A at the high core, the high node count.
The high core count
performance.
Okay.
Yeah. So 96 physical cores, and then we had up to 8 nodes that students were allowed to spin up. The best price performance actually came in at the G40N. That's our GPU instance with one GPU attached to it. And the balance there is actually the accelerator gives you a performance advantage for a lower cost over the cluster of nodes.
Okay. And they figured that out, or at least some of them did.
A small subset figured out how to run on the GPU and how to take advantage of that.
Well, right. So talk about the students' experiences then with this real world challenge in both performance and price performance.
Yeah. So, in the real world, we're always asked a few questions when, especially working with AWS, right? Where folks come in and say, I know how to run an application. How much will it cost? Or can the cloud truly perform as well as on-prem? Or, can you recommend the best configuration to run this application so that I can get started? And that's what we put in front of the students, right? We gave them access to a cluster, and we said, you get to choose what you want in terms of instance count and type. Here's the application, go figure it out. And we intentionally, so we for the first day, we brought in Bert de Groot out of the Max Planck Institute who is a contributor to the GROMACS project. And he came in and he spoke about the actual real world applications and where this application has proved so beneficial for things like drug design and even for COVID-19 research. So they had that awareness of how impactful the application could be. But when they started running on AWS, we didn't give them many details. We just said, you have two constraints on the command line, what you have to use in terms of parameters for GROMACS application. You need to get the best turnaround time, and you need to find out what the best price performance is across all of your different scenarios. And the students went out. We had some that dove into the GROMACS application, understood the different ways to tune the run to change the dynamics that are happening in the code. And most of them just focused on the compiler level, the optimization flags, and changing out combinations of MPI and even testing OpenMP. So we had across the board, we had folks testing different compilers, different MPI libraries, different types of threading, multi-threading, multi-node configurations. I mean, it was honestly the same sort of experience that Sean and I would have if someone were to come to us and say, here's a brand new code, give us the advice that we're asking for. And these are, to their credit, students that had never seen it before, and in a week's time, they managed to do a professional job.
Wow. And you called out one team in particular for doing a professional job.
Yeah. So the results from UC Santa Cruz, their results in particular, the report that they put together, my reaction when Sean and I were going through and grading, my reaction initially was, holy cow, this is so good. I'd be willing to pay for this.
Wow.
As a professional, it's just that caliber, right? So kudos to the students. And that's not just to UC Santa Cruz, it's to all the students that participated. Really kudos to all of you for doing a great job that week.
Well, your challenge was the toughest challenge by a good margin. Looking at your numbers, average was something like 43%, and the average score, and that compares to 67% for NASA, somewhere in the 50.
Or that could just mean that the top team was that much better.
That's right. So
the median was low as well.
Similar to last year. Last year there was a cheat code or a hack, right? You could
loophole.
Yep, the loophole. So last year we had a team pull away from the peloton, and this year it was a very similar scenario where everybody had equal footing. Everybody really was supposed to try running the code on different hardwares with different MPI libraries. They really weren't going to need to work in the logic of GROMACS or tune a fine kernel, right? But not everybody went through the effort of porting to the GPU pool because there were a fewer number of nodes there. And the assumption is that in HPC, scale out is the best way to get performance. And in reality, accelerators are a huge advantage for codes.
Yeah.
And once you get into that space, you start to realize that one GPU can tackle about the same amount of work that 8 nodes, maybe 6 nodes of HPC 6A could handle.
But not everybody discovered that.
Not everybody discovered that.
Well, let's zoom out, though, and talk about the challenge in general. You were saying you were pretty impressed about how the students tackled this. The whole point of the Winter Classic Invitational is that we're trying to bring student cluster competitions, HPC introduction and skills, particularly to schools that don't have their own HPC installations. You get a new batch of students. Is there anyone in here where you're saying, hey, this is maybe someone we want to hire or at least see in the industry somewhere?
So we had a couple of mentoring sessions or office hours throughout the week, and it was an awesome opportunity for Sean and I to talk about our roles as solutions architects. And the students were curious about that. It's clear that the students are ready to enter the workforce. They're looking for opportunities.
What's the job?
Yeah. So, and this is something that Sean can speak to more intimately than I can, but the whole process of getting in as a fresh graduate, or even getting in as a student and going through the internship process and then graduating through the levels that we have within AWS. It's a really cool opportunity. And we were able to share the resources for applying to those different roles to the students. It was everything from basic internship on, like the science side, or even doing code development to build out the next gen HPC services that we offer.
That's cool. And by the way, I need to point out, Sean is a former student cluster competition participant. Couple of times.
That is correct. Yeah.
Did you go to China, Sean?
I did. Yes.
Yeah, I'm going a couple of weeks. They're doing it again.
Oh, awesome. Yeah, that was one of the really formative experiences. So like Evan was saying, I actually came from, my background in HPC was from these student cluster competitions. I got to compete in SC and ISD and ASC, which is the one in China. And those events set me up for my career here at AWS, where I had the skill sets of, okay, let's set up these HPC codes on a cluster, and in some cases do it in the middle of the night before the competition. And a lot of what I learned from those experiences is represented here. Like, for example, at SC, I believe this was 2016, we were really struggling setting up one of the applications, and someone from one of the national labs came over and he said, "Hey, have you heard of this package manager called SPAC?" And we said, "No, what does it do? Please enlighten us." And he showed us how to install the package manager, as well as how to install our application using all the flags we wanted to do, the compiler and the runtime optimizations with SPAC. And that was a huge light bulb moment for myself, because that was something where at Amazon we took a look at SPAC and we partnered with Lawrence Livermore, and then in this student cluster competition, we included SPAC as the way to install GROMACS.
See, in that hands-on experience, I don't think there's any substitute for it, right?
No, and it'll give the students in whatever career field they choose, it'll give the students a huge leg up to be the technical experts with hands-on experience.
That's what we're looking for. Let's make these students valuable and get them in the industry. And at least in the interviews that I've done, there were a lot of students that didn't know HPC is a thing. And now they do, and now they're interested in doing it.
That's a common theme, right? And so Sean, myself, even so, I think back to when I started in HPC. I was an undergraduate. This was almost like 20 years ago now, and I thought I was going to go on to be a Java developer. I thought I was just going to write code full time, and
that was the hot thing back then.
That was the hot thing. Then I started working for a geophysics professor, and he introduced me to HPC for the first time, and my whole life changed. I went on to do grad school, PhD, work in this industry now, because of once you're into HPC and you see where the rubber meets the road, that HPC is how we're solving the toughest challenges. It's how we're able to come up with such brilliant feats of engineering and design, and it's at the core of all of the greatest achievements.
Yeah,
but it's soft spoken, right? We don't. There's not a huge population of us in the world, no. And folks don't talk enough about how critical it is for what we do.
The thing that I've been telling the students in nearly every interview is that if you're interested in working on the world's toughest challenges on the world's biggest computers, this is a job for you.
Right.
Yeah, you get the pace of technological development meeting the entire breadth of scientific and engineering discovery, and you don't run out of problems to solve. And the industry changes every year. It's an exciting place to be an analyst.
Yeah,
absolutely. Well, we just can't thank you enough for doing this. We really appreciate your second year. Glad you came back, and hoping we'll do it again sometime. Next year.
Absolutely. Yeah, we love to do this. We love working with the students, and it's the next generation, right? And to Addison's point,
that's why we need them. Yeah.
Some of them we will see in the same field as us, and some of them we will hire for jobs. So it's always good to work with the students early on and often.
I know the students really appreciated it, and the feedback has been great, despite how difficult the challenge was. But they just loved working with you guys. So thank you again.
We'll keep updating the leaderboard. Saran, go ahead. Sorry, I cut you off.
Yeah, and to all the students, if you're listening, please reach out. Don't be a stranger. What you'll find is that the HPC community is very accepting and accommodating. Be happy to talk beyond the competition. If just reach out via LinkedIn or Twitter.
Fantastic, and I'll make sure you guys get a copy of all the resumes too.
Wonderful.
Well, thanks again. You gonna close us out,
Evan,
Addison?
Yeah, for you and all of your colleagues, for all the resources and mentorship at AWS. Thank you for supporting the Winter Classic Invitational. We look forward to seeing you back next year. We'll keep updating that leaderboard. Stay tuned in. I think we've got a tight finish ahead.
Excellent. Looking forward to it. Thanks, guys.
Thank you.